This session is being recorded, and it will be posted in the recording presentations site later on this afternoon on the left-hand side. To those of you that are with us now live, and those of you that want to come back and review it later. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm missing somebody. Hang loose. Oh, I got it. It's okay. I lost my mind for a month there, but I'm okay now. So I went in the 90s and I worked for outside industry company. I worked for a college textbook publisher, Harcourt-Brace College Publisher. So I know all about that textbook scam business, about making your used textbooks absolutely worthless in the marketplace. And then in 2020, the Cisco Network Academy came into being, in the very late 1990s. So it was Cisco's corporate program where they have donated a lot of resources and actually financial stuff to, did you know there's 10,000 networking academies? There's over 10,000 network academies throughout the world. It's the single most successful e-learning initiative there is in the entire world. We have had over 10 million students so far. And so it was a program that Cisco developed to help people to get first of all, the CCNA certification, which you guys are, if you take all the 4 courses here from Tarrant County College, you'll be fully prepared to pass the CCNA certification test, which is a great certification. It's a jobs training certification. We call this field of education here career technical education, school to job connection, where when you go out with a career certification like the Cisco CCNA certification, it puts you in a better position when you want to go out and compete in the marketplace. So I'm going to cover that a little bit. I'll show you that website. Invitations have been sent out to all you guys. I see that most of you have actually signed up and been on there. It's a very easy click to go on there. You basically have to make up what password you're going to use on the Cisco Network Academy site. And that site is where you're going to find the free ebook. Yeah, we've been doing the free ebook thing for 20 years now. This is not like the other course you might have taken that I joke and I call it the Computers for Terrified Adults class, like a basic computer literacy class, where you can take it in an option where you get it as an ebook, and then the day after the final exam, your ebook dissolves into smoke and you can't have it anymore. Well, we don't do that at the Cisco Network Academy. We're going to give you this ebook free at no cost forever, and you're going to get access to it forever. So we'll look at the Academy in a little bit and see how that works. Now, normally we would be having this session on Monday morning because the course is set up for on Mondays at 9 o'clock. I do the online lecture where we use the Cisco Collaborate, which is a Zoom-like software. And then on Wednesdays, normally on a Wednesday, we would be meeting at the South Campus Cisco classroom, the laboratory classroom, SVUS 1125. But since there was a holiday on Monday, that's going to start place next week. So in the future, on Mondays, we will meet online, just like we're doing now, at 9 a.m. And I always record the lectures and the presentations, so if you can't make it or you want to come back and listen again and review stuff, that's going to be posted on our on the Blackboard page for this particular site. So starting next week, our first meeting in person will be next Wednesday, a week from today, at 9 a.m. at the South Campus building. And you can come in person if you want to. If you don't want to come in person any or all the days, your choice. You can use the Cisco Packet Tracer software to do the particular labs that I have used set up for this particular class. And I'll record some part of that part as well. When you come in person, I think it's more of value when you come in person to the class because you can get your hands on the real Cisco equipment and learn some troubleshooting techniques in person from an insider guru like myself who's been teaching this thing for over 20 years. You can also have the option of doing the labs remotely using this free Cisco Packet Tracer software that you can download for free from the Cisco website. And I'll show you a little bit more about that later. And I'll record some of that. Generally speaking, I'm going to have a recording, lab-based recording, both for the real Cisco equipment in the lab, and then I'll record a little walkthrough for if you're using Packet Tracer from home. Okay, let's see now. The next thing I want to do is, let me blank this out. Hey, someone's got their camera on. Good deal. No one ever turns their camera on around here. They don't want to see what they look like, what they look like. Here we go. We're going to share the application. I'm going to share the application. That's the my TCC Blackboard. Okay, when you log into my TCC Blackboard with your, john.smith@my.tcc.edu, your Tarrant County College login, you get something like this first. And this announcement, what to expect with your class, I also emailed that to everybody. And I talked about some of the things that's going to be happening on this course. If I make an announcement, I'll probably make another announcement later today after I post the first lecture session, just letting you know that it's available and you can see it on the recorded presentation site. Now, let me see here. I got to click over to this thing here so I can actually click on it. And let's see, is my mouse up here? Oh, good. My mouse sort of ghostly appears on the screen here. So this is what you see when you first connect to your Blackboard page for this particular class. And other teachers, if you're taking other classes, will have similar pages that they're doing. I see somebody popped in here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Okay, good. Good attendance. Now, I'll talk a little bit more about the grading scheme when I get into that portion of the so-called syllabus, the instructor course requirements. But when you click on My Grades and the Blackboard, it shows you, basically it's going to be 50% of your grade is going to be based upon a couple of tests that we take online on the Cisco Network Academy system. And then the other 50% of your grade is going to be based upon, it looks like, 8 labs that you will do. I do drop the lowest lab, so you can skip 1 lab. I drop the lowest lab grade, so you can safely skip 1 lab and it won't affect your grade any. There's another lab that I will be doing, a 9th lab as an instructor demonstration, but you won't be graded on that. You won't have to turn in any lab reports on that one. Blackboard, we're getting rid of Blackboard. I think it's great, but other people have made the decision that we're going to switch to another learning management system called Canvas. Canvas is a system that the Network Academy used to use, and they switched to one called Moodle. So we're kind of running behind and chasing Network Academy. Well, they got 10 million students. We only got 100,000. So there's a little bit of Blackboard nonsense. When you look on this, I always get a complaint every semester when people look at their grades in Blackboard and they say, I didn't get the maximum credit that I should have. And that's because I have to put in larger numbers in the Blackboard when I configure it than what you actually can get so that I can successfully put in your grades. You're going to get a total, if you do all your labs or all your labs minus 1, you're going to get a total of 50 points for that. If you do both your tests and you get 100 on both the tests, you'll get the full 50 points for that. So, and you're going to see some similar nonsense on the Cisco Network and Academy side. But we're required to enter our grades into Blackboard, and the final number you see in your Blackboard grade sheet will be what your final score is. But that's not going to be accurate really until about the last week of the class, because I'll have to take the stuff that you did on Cisco Network and Academy and sort of punch it into the Blackboard scheme. Okay. Course evaluation, if you click on that, does it pop up and change here? Okay, when you click on that toward the end of the semester, that's an optional thing where it's not going to work because I'm a teacher. I'm not really signed into this class as a student, but you'll see the courses that you're taking and you can evaluate them. This is a student satisfaction survey, and it's anonymized to where no teachers can see anything that you say, and it's not available for the teachers to see until all the final grades are turned in. And this is sort of collected because the college likes to collect this sort of stuff about how they're doing with the students. We have 100,000 students, so we want to see how they feel about this. You don't particularly have to take that if you don't want to. We can't force you to take that. Now, when we had in-person classes, we would chase me out of the room, and the lab manager would come in and say, everybody log into WebAdvisor and please take this evaluation now. So we had higher completion numbers. Now, there will be another student satisfaction survey that you have to take, and that's from the Cisco Network and Academy with their 10 million students. And the way they make you take it is you can't take the final online exam until you take the customer student satisfaction survey first. And they've got a fancy name for it. They call it the course feedback form. And I'll turn that on later in the semester and tell you about that. Now, we're in the Blackboard Collaborate Now online meeting. And I will post that every week before we meet. I will post a new link there where you can click in and join the session for that particular day. Okay, course presentation materials. Is it popping up correctly here? Okay. So these are the 9-chapter, I call it death by PowerPoint. So I'm going to be the invisible talking head, and I'm going to cover the PowerPoint slideshows and try to fill in with some of my years of experience. I'm trying to get my knowledge back to the community. I worked in the industry as an IT person for many years, and now I'm trying to do something in this career technical education courses that we teach here at South Campus. We have other Cisco sections. We also teach at the Northeast Campus and the Southeast Campus. So today we're going to cover the Chapter 1 material, but not quite yet. I want to cover some more stuff. I'm going to click on the next link, Student Lab Printouts. So when we come into the class next Wednesday, this is the lab we're going to do. And the real lab equipment, we've got real lab equipment here at the South Campus SBS 1125. We're the first ELE, instructional. This is educationist jargon. I won't call them educators. They're educationists. Okay, they have master's degrees in education or something like that. This first lab, we have some real equipment here. We've got real Cisco routers, real Cisco switches. We have a bunch of student workstations that are running virtual machine software, so we can have each student consider this private PC, and he can have 2 computers, 2 PCs running in virtual machines. We use VMware Workstation, and you can connect your switches and routers and build simple networks. Our first lab will be building a simple network. As we go through the course, I will post in this recorded presentations. Someone just trying. I can. As we go through the course, and I record the lab presentations, and I record like today's session, the lecture sessions, I'll post them in the recorded presentations portion, and they'll show up, and the link will show up here. I have some stuff here already. For example, there's this Cisco Packet Tracer program that Cisco Network Academy you can download for free. And I've got a click here. This is a link to a YouTube video with another Cisco instructor that shows you how to install Cisco Packet Tracer. And if you have a Microsoft Windows computer, if you have a Macintosh computer, they even have a version for Linux. I haven't messed with that much. Linux is kind of tricky. Although, let me say this at the outgo, if you intend to have a career in information technology and networking, besides studying Cisco, one of the most valuable things you can do is learn something about Linux, because all of the network management utilities that are coming out are Linux-based. Even the newer Cisco routers are actually running Linux. Now, maybe you have an older computer and it just doesn't have Windows 10 on it, and you have problems installing Cisco Packet Tracer. Or I had a student last semester that had an older Macintosh laptop computer, and it was having trouble running the Macintosh version of Cisco Packet Tracer. Our IT people have put together, we have a big data center downtown in our Trinity River campus that used to be Radio Shack. And they have a whole server rack system there of what are called VDIs, virtual desktops. This is like running VMware Workstation or a VM type software. And they have configured a Windows 10, it's called the Student Workspace. And in the Student Workspace, you have access to a Cisco Packet Tracer program. It's as if even you have an old crummy Chrome desktop that doesn't have any power capabilities, any features at all, so long as it has a web browser on it, you can connect to this and use a high-powered version of Cisco Packet Tracer running on a high-powered Windows 10 machine. And that's present in your My TCC Blackboard before you log into this class. Before you click on one of your classes, it's in the left column. It says TCC Virtual Infrastructure, and then click Student Workspace, and you can use those. And I have a little user's guide, a PDF user's guide. This is the last thing that's pointed here. Now, I want to go over the class syllabus. So I'm sure you're anxious to learn, hey, how I figure the grades and what's our schedule for this 8 weeks we're going through and things of that nature. So hang on just a second, and I'm going to share that for you. Oh, where did it go? Did I minimize it? Hang on just 1 second, I'll find it. Okay, there it is. Okay, so these educationists that I referred to, you remember when you went to high school? There was a bunch of teachers, and there was like one principal and maybe 2 assistant principals and some lunch ladies and the janitor. Okay, so it was mostly teachers. Well, in higher education, we've got more administrators than we do teachers. Goodness gracious, we got, the vice president in charge of, vice chancellor in charge of diversity, inclusion, all this other stuff. So we would normally call this a syllabus. Syllabus is how the instructor sets up his course. So our educationists, our administrators, they don't teach much, they're administrators. They call this an instructor course requirement, ICR. So that's what it's called in our system. When you go into WebAdvisor, you can click on your schedule, and the left-hand link that says ITCC 1414-1700 will be in blue. And if you click on that blue link, you can bring it up here. And I've also posted it here in my TCC Blackboard, where you can click on it. And what you see is this. So here's me. I go by Mark instead of William, but they're forced to use the system, the WebAdvisor system has to use your first name. And I go by my middle name and not my first name. And it lists my email. We're very liberal about drop dates here. You can drop pretty much like next to the week before finals. You can drop up to that date if you don't want to complete the course for any reason. And when we had in-person hours, I would go in my office. That photograph you see of me is in my office at South Campus SBUS building. And we have office hours. So now it's done virtually. So my office hours, I have 9 o'clock classes on you guys on Mondays and Wednesdays. I have another Cisco class, an advanced Cisco class on Tuesdays and Thursdays. And they have a virtual lecture on Tuesday, and they come in for a laboratory on Thursdays. And our class is scheduled to last from like 9 to 1:30, but I tend to talk fast, and this is the first class, and we won't be here till 1:30 today or whatever time I'm posted. So in the South Campus, there's a business building, and in room 1125, which is on the bottom floor, it's right next to the dean's office, is where what the education is called integrated instructional learning environment. It became a buzzword a few years ago. Well, in Cisco, again, like the free ebooks, we've been doing this for 20 years, which means we have a single room you can come into, and you can see your death by PowerPoint there, and you can log on to the Cisco devices and build your labs and do your hands-on laboratory experiences all in that one room. Okay, let's see. Where did it go? Yeah, page down here. I don't want to blind you guys by doing it. So here's some stuff the lawyers made us say. I'm not going to read this to you, except at the very bottom. Well, student accessibility resources. Like if you're a veteran and you've got a bad back and you want to come to class to the laboratory section, they'll do things like bring out a special chair for someone that's got a bad back. And any type of disability that you have, you can contact them and they'll help you out with that stuff. Now, at the very bottom where it says no required print text, free online access to all non-print media will be furnished. The mouse, ghost mouse right there. This is the free ebook that the Cisco Network and Academy is going to give you, and you're going to get free access to it forever. So the Cisco Network and Academy, which we're going to look at here in just a second, at netacad.com, I sent out an invitation to everybody. I'll show you how to resend that invitation if you didn't act on that or lost it in your email. That's going to be the electronic ebook that contains all the information for this particular course. It's also where you take your online exams. Now in this course, there's 2 exams. There's a kind of a midterm and there's a final exam. And that also has printed versions of the laboratories, but as a convenience, I've broken those out and I posted them on my TCC Blackboard. They're Microsoft Word documents. You can click on them easily and get into those and start using them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, got to check my attendance. And that's a free website. They won't be any charge for that stuff. Okay, so CCNA Network Essentials, what Academy calls this stuff. So this is going to be an introductory course where we look at network technologies, look at how devices access network resources, we're going to do some basic simplified settings on a network devices. For example, we'll set up a Cisco switch, which switch is a device that usually has like 24 ports in it, and you plug your 24 employees or students into that one switch, and they're all connected to the network. And then we'll look at setting up some basic network connectivity between devices. So like the first lab that we're going to do next Wednesday, we're going to plug 2 PCs into a switch. And by default, the switch needs a configuration. It'll work just fine. And we'll configure those 2 PCs so they can talk to each other using a little test we call ping. Ping is kind of like sonar in a submarine. Ping the battleship and shoot them with a torpedo. Ping is a utility we use in networking to see if we have basic network connectivity between 2 devices. Now, since the uncertainty of the virus has occurred, we've changed our grading scheme a little bit. We used to require you to attend all the lecture sessions and require you to attend all the laboratory sessions. But now our lecture sections are all done remotely, and you can come to the laboratory. I encourage you to come to the laboratory in person. You get more value out of your equipment. But if you don't want to come one day or any day or whatever, you can use you can do that remotely using the Cisco Packet Tracer software. And when we have our labs, if you want to come in person, don't come if you're sick, but you can come to that South Business Building, SBUS 1125. Now, to get a grade in this course, all you got to do is complete, it says chapter assessments. There's only 2 tests in this particular course, this introductory course. It has that one midterm test for like chapters 1 through 5, and then a final exam. And the laboratory, we have like, I think we have 8 laboratories that I've assigned to you guys, and you complete 7 or 8 of those, and that'll be the other 50% of your grade. Okay, the way I figure the grades is I'm kind of like the IRS. You know, if you have to pay the IRS and your taxes are due, and it's $89.51, they don't want you to send $89.51. They want you to round everything to an even dollar amount. So it works both ways. So if you got a refund coming from the IRS and your refund was $79.57, they're going to send you $80. 80. They don't want any cents in there. And that's the way I do the labs. So if your final grade is a numeric average, which we're required to calculate and put in Blackboard in the grades page, if you have your final grade is 89.5, it's 5-4 rounding, it'll round up to 90, you get an A. So we don't give minuses and pluses. You either get an A or a B or a C or whatever. Okay, so due to the uncertainty of the virus, what we're doing is the lecture classes, which normally would be Mondays, and we will meet Monday, cover chapter 2. They're going to be remotely using the My TCC Blackboard Collaborate, which you're on right now, and it's, you know, it's kind of like Zoom, kind of like Cisco WebEx. So log in every Monday morning at 9 a.m. to attend the live session. It will be recorded and posted later if you had to miss it or you want to go back and hear a section again. When you click on it, it's going to take you to a YouTube video, which I've linked to in the recorded presentations page. The laboratories will normally be on Wednesdays, but we're not having a laboratory today because we didn't meet Monday. It was a holiday, a student holiday. And I'll record some stuff in the labs too and post that as well. So if you don't want to come to any or all particular lab sessions on Wednesdays, you have the option of using the Cisco Packet Tracer software, which I'm going to show you on the Cisco Network Academy side in just a minute. So today, Monday, we were closed. TCC was closed. There was no class. We all were on holiday. So today is Wednesday, and we're having our first remote session through the TCC Blackboard Collaborate Ultra Zoom-like software. So no in-person lab today. If you went to the lab, it's going to be locked up. You won't be able to go in there, but you can come starting next Wednesday. So today I'm going to cover the Chapter 1 Death by PowerPoint presentation after I cover all this introductory stuff. And then Monday I'm going to cover Chapter 2. And then a week from today, on the 27th of January, we'll have our first in-person lab opportunity. Starts at 9 a.m. in the morning. So if you want to come to the in-person lab and get the benefit of working on the real stuff in person, you can do that there. And we're going to continue like that for the rest of the semester. Every Monday will be an online remote lecture. You stay home, you log in, watch it later on the recorded presentations, YouTube if you want to. And then every Wednesday will be at 1 or 2 labs. Now, this is an 8-week course. The reason we offer these courses, a lot of our career technical education technology courses, particularly jobs training stuff like Cisco CCNA, we offer on an accelerated 8-week schedule. So instead of taking it more slowly over a 16-week long traditional semester, the entire spring semester from here to May, this way you can take 2 courses in 1 semester. So the Cisco Academy has 4 courses. So if you took it in a normal 16-week load, it'd take you 2 years, take you 2 academic years. Well, you're anxious to go out and get certified and get into the workplace and start earning some big network engineering technician wages. So we offer it on 8-week sections. So you're in this course now. After spring break, you can come back and take the CCNA 2 class. That'll start Monday, March the 22nd. It'll be the same thing as this. It'll be lectures on Monday and it'll be laboratories on Wednesday. We used to have to, when we were in person, you would come on a certain final exam day, the last week of class, and you'd sit down and take your final exam. And it had to be at that particular, like it was like 9 a.m. on that Wednesday or something. But now the deans have asked us to make it easier for students that, to finish this final exam requirement. So you have a week. You still only have like an hour and 15 minutes to take the final exam, but you can take it anytime you want to from 9 a.m. on Wednesday, March the 3rd through 9 a.m. Wednesday, March the 10th. You can take that final exam. You only get 1 try at that one. I give you several tries at the midterm. And by the way, all the online exams I've configured to be open book. Now, Cisco has a business rule or a business requirement that before you can take the final exam, you have to take their student satisfaction survey. It's called the course feedback form. And I think the reason they did that is they don't want students to take the final exam and then get mad about the grade they got on the final exam and then give me a bad review. So they make you take that first. And they ask you silly questions like, oh, how well do you think this course has prepared you for a future as a technician or engineer in the information technology field, things like that. And this student satisfaction form and the one we have on Web Advisor, which you don't have to take if you don't want to, this one you got to take. This is your one chance to comment on my choice of bath soap. Anything else you want to say about me, you have an opportunity to say that. So since the semester ends that week of Wednesday, March the 10th, I'll tell you about our dean. Our classroom is next door to the dean in the business building. Okay, the dean was in the Marines for 30 years. Okay, he don't take no guff. I have to turn my grids in Wednesday afternoon, and there's no way around it. So all the work is going to be due by 9 a.m. Wednesday, March 10th. And there's no incompletes are almost impossible to get now because if you haven't been completely in your work and it's not the last week of class and something weird happened, they're almost never going to grant an incomplete. So if you don't think you're keeping up with it, the better choice would be to drop the course if you're way behind then, because I don't take off for late work. But if you wait until the week before the class ends and you haven't taken any of the tests and you haven't done any of the labs, it's going to be overwhelming to you. It's not that much work. This is the first class. It's a fairly simple class to complete. Okay, well, that sounds terribly distressing. Sorry about that. So I have changed the scheme to 50% of your, what he says chapter exams here. It's actually the midterm and the final exam. That'll be 50% of your grade. I'll just average those 2 tests together. And then 50% for the average of all your laboratories. And then we're using remote for lectures and then laboratories. You can do them remotely with Cisco Packet Tracer software. And then you can come in if you want to on Wednesdays at 9 a.m. and do it on the real lab equipment if you want to do that. I have posted the Packet Tracer installations. I showed you that in the recorded presentations. So the Cisco Network Academy.com site is going to be what you log into to see the free ebook, to take the 2 exams. The laboratories are Microsoft Word format. So what you can do if you want to do the lab, if you come in person, you can just use our printer, print the lab out, put your name on the top of it. I think there's 1 question on the first lab to answer and turn it in. If you want to do it remotely, what you can do is download that Microsoft Word document for that particular lab and edit it and put your answers in there and then email it and send it to me. And it would be helpful if you would edit the file name and put your last name in all capital letters at that file name so I can tell it apart from everybody else's. And the second little warning here is pay no attention to the number grade values you see in my TCC because of the Blackboard nonsense of the Cisco Academy site. But the final grade you see will be accurate. We are currently doing we had a attendance policy that if you missed more than 15% of your classes, now that's only 3 meetings in the 8-week section. You could be dropped at the discretion of the instructor. We're having a forbearance policy there now, which means that we're not enforcing that. So if you get a distressing, panic, nasty gram from WebAdvisor saying, oh, you've missed a class, oh dear, you could be dropped, pay no attention to it. I ain't dropping nobody. You have to drop yourself if you don't want to take the course. However, the state legislature several years ago, the Texas state legislature, oh, what was it that Mark Twain said? Your life, liberty, and property are in immediate jeopardy because the Texas state legislature is in session. Well, they passed a law that said that if it's a Texas public university or junior college, you only get 6 lifetime drops. So you can't take the course again after you drop it. 6 lifetime drops on all courses. So think carefully if you need to drop the course. You don't get that many of them. Okay, is that all? All right, good. Now let me see. I can stop this. Stop sharing. Click that. And I need to show you guys the Cisco Network and Academy site now. Oh, someone has asked the question, what's the difference between CCNA 1 and CCNA 2? So with Cisco, thank you very much for reminding me about that. About a year, almost 2 years ago, Cisco reorganized and revamped and sort of changed the objectives and the what we call the sequence of the stuff that's in the Cisco Network and Academy. So CCNA 1 is now a sort of introductory course. And CCNA 2 is the full introduction networking course that has the dreaded, feared, and hated subnetting and binary math and stuff like that. That's what we're going to do in the second 8 weeks. And then CCNA 3 and CCNA 4 are the more advanced courses where you'll learn to do some more advanced configurations and routing protocols and security and things of that nature. Now, I need to show you the Cisco Network and Academy and how to negotiate around that. So let's see, I'm going to hang loose while I bring that up. Okay, so you go to netacad.com, and this is what you see. And it's really weird the way this login thing is. On every time I do it, I have to sort of float the mouse. Let me go to the real screen here. I have to float the mouse over the login and then click the word login. And I sometimes have to do it twice. And then it'll go to the login screen. But let me show you what else is here. If you've forgotten your password, teachers, academy instructors can't reset your password. Also can't reset your TCC password. There's a tech support link for that, or you can click on I forgot my password when you try to log in. But I know you guys got past that little hurdle. Yeah, that was your first skills-based assessment, is successfully logging into my TCC Blackboard so you could join this Cisco Collaborate real-time session. So if you forget your Cisco Network and Academy password or problem with it, you can click on Forgot Password, and they'll use your email and click you something. You know how it goes when you forget your password. They send you an email to your real email, and you click on something, and then you get to reset your password. Now, I noticed that about several of you guys, 4 or 5 of you guys, have not yet activated your Cisco Network and Academy account. So if you can't find that email that you got from Cisco, click on where it says Resend Activation Email, and it'll ask you, well, what's your email address? That's your, john.smith@my.tcc.edu, whatever your actual number is. They'll send you another copy of that. But normally you're going to click login. Okay, so I'm going to go in here and click login. I'm going to put in I have a test student account that I use. So you can see what it looks like for students. Teachers got extra stuff the students don't get. So if you put in your Cisco Network Academy username and password, you get something like this. Now, you guys are this course, Networking Essentials. So to launch that course, you go here and you click Launch Course. It says week 6 because I created this course a long time ago. Don't worry about that. That's more nonsense, LMS nonsense. Okay, so here we are at the course home. See, 2021 spring semester, ITCC 1414. That's our class here. And here are the chapters. Here's the ebook. So if you click on Read Chapter 1, it's going to pop up a window that says Launch Chapter 1. It's going to open up a new tab, and you can start reading the free ebook stuff. And you click through, and you can see the stuff. This is the chapter I'm going to cover today. I'll click on Course Home again. So after we get through chapters 1 through 5, there's going to be, it's kind of like a midterm exam. He calls it a checkpoint exam. I haven't activated that exam right now. So if I click on that, it's going to say, well, the exam hasn't been activated. I'll turn that on later on in the semester. And so we have our 9 chapters. And then here's that course feedback form. So if I click on that, it's like taking a test. I haven't activated it yet. And then when we get toward the end of the semester, that final week where the final exam is turned on, I'll have turned on the course feedback form where you can click and take that student satisfaction survey. And then the final exam will be turned on where you can take it. These are multiple choice type questions that are either have a circle if there's only one possible answer, or it'll have a square, and at least they'll tell you how many. He'll say something like select the 2 best answers, and they'll give you 5 things to choose from. Okay, so let's see. In the grades, you'll get some grade for your checkpoint exam, your midterm thing for chapters 1 through 5. The course feedback, I don't care what you say about me. It's not graded, and I can't see who did it. They're not graded on that. And then you'll get a grade for the final exam, and that will be the average of those 2 grades. That'll be 50% of your grade. And the other 50 points of your grade will be from the laboratories that we do here. Those won't show up here on the Academy. Those will show up on your TCC Blackboard. Okay, I think I've showed you everything I need to about the Cisco Network Academy site, so I'm going to stop sharing that. Someone has asked, when do I plan on activating them? I will go ahead and activate the Chapter 5 midpoint exam probably in a week or 2. It's going to take us 5 weeks to get to that point, but some people like to read ahead and do stuff ahead. The final exam will only be activated during final exam week, that week in March from 9 a.m. for the first Wednesday to the second Wednesday. It'll be active during that entire time. It's normally only active for an hour and a half when we come in person, but we're not doing that right now. Okay, so let's go and do some PowerPoint stuff here. And it takes a second for this pop up, but eventually you should see a Cisco web slide show coming up. So here we go with Networking Essentials. Oh, look, it's only 16 slides and a couple of them are title slides. So this shouldn't take too long here. So here's what we're going to look at today. So this first concept is communicating. We're going to look at this concept of network communication. The second part is local networks. So no fair, I haven't used the term local area network yet. What the heck does that mean? So a local network is a network that's like, at your house, you've got a local area network. You got your home router, you got some Wi-Fi attached devices, maybe you got some plugged in desktop computer devices. And then we'll look at building a simple network, how to build a small, functional, very small base network, like for what Cisco calls, you've heard the expression SOHO, SOHO, small office, home office based network, or small business based network. And in our first lab, we're going to build a simple network. Next Wednesday, we're going to just take 2 PCs and plug them together into a connection device called a switch, and we'll build a network there. Okay, let's talk about this, communicating in a connected world. So everybody likes to be online now. We have online connectivity with all these devices, desktop PCs, telephones, and it's all using this thing called the internet, which is not owned by any one particular company or corporation or government. It's the term internet means it's like interstate truck traffic. Interstate trucks travel from state to state. Internets connect all these individual, maybe privately owned, maybe publicly owned networks from corporations, universities, people who have internet service. It's all connected together. No one person owns this whole outfit. So in theory, this internet thing was built back in the 70s, where they said, well, what if we want to build a network system that would survive disasters like fires, earthquakes, atomic bombs, whatever, so we could still do stuff. Now, the telephone company, which has been around for over 100 years now, has this science already perfected. So for example, if it was Mother's Day and you were calling somebody and there was not a direct circuit from Dallas to Chicago, he would automatically use a alternate where he'd go through Omaha and Duluth and then use that circuit to Omaha to Chicago so you could talk to it. So the internet is a similar scheme. There are many possible paths that your network packets could take from one network to another. And a bunch of really smart people stayed up late one night and figured out how to make this work so that you didn't have to worry about it. You could just type send or click on a website and you could get that back to you real fast. So a worldwide interconnected networks. And we use telephone wires. For example, I have my internet connection at home is through AT&T, the Death Star. I think most people in my classes have said they prefer the cable companies. So it could be coaxial cable, it could be fiber optic cable. Both the phone company and the cable companies are now upgrading their systems with fiber optic. Could be a wireless transmission if you're using your telephone as a hotspot. It's using radio waves to talk to a cell phone tower. Maybe even satellite links. So if you're in the middle of the desert in Arizona, there's no wires to plug into, but you can actually uplink to a satellite and like use satellite function and get your internet service in that fashion. And a laptop PC and an Xbox and tablets and telephones, and they all can connect through your home router is the central device that connects these things all together. Small office, home office, even large networks. Tarrant County College, it's got a very large base network. We have 100,000 students and 4,000 employees and lots of campuses, and they all have to be interconnected together. And then besides all these individual devices, we have to connect them somehow to the local networks. So from your telephone, it could be through that cellular tower, or when you're at home, maybe you have it connected to your home Wi-Fi based network. All types of devices would connect to a local network through twisted pair Ethernet cable for a desktop PC, maybe through Wi-Fi, through some method. We've got to set some way of sending these bits back and forth that establishes communication between all these different devices. So they're all, in the end, the physical level, but think about a telephone. You pick up the telephone and you start speaking into it. And does the telephone care what language you're speaking in? He really doesn't. The only thing his job is to convert the sound wave impulses that you're speaking into the mouthpiece into an electrical signal, and he transmits that electrical signal to the telephone number of the person you're calling, and he hears what you're saying. So the telephone doesn't have to, there's not an Italian telephone and a Yiddish telephone and a Russian telephone. All telephones work great in any languages. They just recreate that sound and send it as electrical impulses to the other telephone, and it's turned back into sound waves to that telephone earpiece. So in computer systems, at the very lowest level, everything has to be turned, no matter what kind of data it is. So we could have data that's like a YouTube video. We could have data that's like a graphical image on a web page. We could have data like an email message. We could have data like numerical values. So we have a big database of what grades you make and what salary the instructors get. Everything is eventually represented as data as numeric values. And at a very basic level, we have to eventually turn them into these bits, these ones and zeros that travel throughout the network from one point to the other. So it doesn't matter whether you're using like wired Ethernet or Wi-Fi or cellular telephone information. Eventually, everything is going to be turned into ones and zeros and sent as little electrical bits through the wire, or little electrical flashes of light through a fiber optic cable, or little radio waves representing ones and zeros through a cellular telephone network. So networks transmit their data so they can share it with others, or maybe to store it. So, hey, I got ahead of myself. I called it bit before we got to the bit slide. So everything eventually is turned. Now I've said the telephone doesn't care whether you speak in Italian or Yiddish. The wire doesn't care what language you're speaking, what data you're sending. All he cares about is my responsibility is to transmit these ones and zeros, these bits, from one point to another point. So in the first lab, we're going to do that first left part. We're going to connect PC A to PC B with electrical cables, Ethernet cables, and they're going to be able to ping each other. I use the term ping, which is a little test we can type to make sure that we're able to network and connect with another device on the network and prove we can talk to it. So let's see, if you took your Computers for Terrified Adults class, you might recall that the bit is the smallest single bit of information on a network. Eventually, these bits are going to be combined, and they're going to represent numerical data or computer instructions or YouTube videos or graphical images or emails or whatever we need it to do. But it's eventually going to be broken down into ones and zeros, these bits. And the most single lowest common denominator here is we're going to take each group of 8 bits, and that's called a byte. That's 8 bits, called a byte, B-Y-T-E. And that numeric value, that 8-bit value, and let's see, I'm not going to try to scare you guys too much with binary numbers, but when you have zeros and ones and you have 8 bits, that's 256 possible different values. Each one of the 8 values can be a 0 or a 1. So if you take, oh gosh, 4th grade math, 2 to the power 8 is 256. 256 possible combinations of 8 zeros and ones. And these 256 combinations could represent numbers from 1 to 256, could represent alphabetic characters in ABC, could represent a computer instruction like add 2 numbers together and put the result over here. So that's our smallest group. It's called a byte. So to get these bits moving, we're going to transmit them over a copper wire. We're going to transmit them with these little tiny electrical currents. They're very small currents. They cannot shock you. You can't even feel them. But they transmit over the wire. So if we have a twisted copper Ethernet cable connecting 2 devices together, just so long as that cable isn't too long, we can successfully, these are little minute particles of electricity, and as we say out in East Texas, they get petered out if you go more than a maximum distance. So we got to gussy them up and strengthen them up again. And it turns out that with copper cables, your limit is about the same as the distance between the goalposts in a football field. It's really 328 feet, 100 meters is the furthest. And when you get more than that, the intensity of the electricity fades so much that you can't depend on it anymore. You got to re-strengthen it, gussy it up again. So with copper cable, that's the reason why in every building in the world that has computers in it, there's a central wiring closet somewhere where all the wires come from every room, every classroom, every office, and they converge like in a spider web in that central wiring closet, and they all plug together into an electrical device we call a switch, an Ethernet switch. He plugs them together. And he regenerates, and the electrical switch gussies up and regenerates the electrical strength in case it has to travel another 328 feet to another device. Now, fiber optic cables, if you guys have been on the South Campus or any of our other campuses yet, it's oftentimes more than 328 feet from one building to another building. So instead of using twisted pair copper, which is okay inside the building, because most buildings are less than 600 feet from side to side, I can just put a wiring closet somewhere in the middle of the building somewhere and plug all the devices. Our SBUS building, we've got, oh, this question has asked class participation. That's just something I put in there because the dean made us do it. Your grade, your 50% grade is going to be based upon those 8 labs that you complete. And since the troubles of the virus, we got a lot less strict on that. You know, if you don't come online here, you're not going to get an absence. You can watch it later remotely and watch it on the PowerPoint slide. We've been told to be very easy on here. I'm already pretty easy anyway, but this makes it even easier. So if we want to connect, say, the South Campus Business Building to the library, well, that's more than 300 feet. And what am I supposed to do? Go in the middle of that little free speech pavilion and dig a hole and put an electricity in there? Oh, the question is asked, where is the book located? And it's on the Cisco Network and Academy site. You log into the Cisco Network and Academy and click on the launch the course, and there will be a link there to read chapter 1, read chapter 2, read chapter 3. And you got to click about 3 times on pictures to get to it. So if it's more than 300 feet from our South Campus Business Building to the library, I can't just dig a hole in the concrete and run an electrical circuit and put a repeater in there to re-strengthen those signals. Instead, I'm going to use fiber optic cable. So fiber optic cable doesn't have this football field limitation. Its limitation is more like a mile or 2. So on a campus like ours, it's very easy to run fiber optic cables. And instead of sending electricity through a copper cable, we send pulses and flashes of light through a fiber optic cable, and it's very easy to get longer distances. So if you come to campus, you'll notice there's no telephone poles, no power wires sticking up in the sky. It's buried in the ground. There's a system of tunnels that connect all the buildings together. And I've been down in all there, because back when I worked in the 80s, we would run our mainframe coaxial cables to all the offices and the dean's offices. So fiber optic cables are connecting all our buildings together, and that's how we get our connectivity. And you can show up and, oh gosh, you're not allowed to bring your device to campus and plug it into the Ethernet system because it's probably loaded with viruses or something. But we give you free Wi-Fi service. So that's the last one. Wi-Fi or cellular service is using, oh yes, it is a good bug out location because it's very dry down there. I've been down there a lot and there's no bugs. You bug out in a bug-free location. It's pretty dry. Radio waves is an alternative to actually having to run a piece of fiber optic cable or to run a coaxial cable. As a matter of fact, in a lot of new office environments, they're putting in Wi-Fi systems because that way you don't have to run those Ethernet jacks, those RJ45 wall panels everywhere, and then some guy in a corner office who's a vice president decides he wants to move his desk over to another location, and now we got to run a long cable across the floor for people to trip on or something like that. Well, if we put Wi-Fi service in there, and Wi-Fi's gotten really good lately, really fast and really secure. Well, we can just blanket the whole office building with Wi-Fi, and you can go wherever you want to with your desk, and we don't have any wires to trip over. And a lot of home users like Wi-Fi because they can connect their telephone or their laptop computer or tablet or something like that to the network without having to actually run wires. So bits are transmitted over copper cable or fiber optic cable with flashes of light, or as radio frequency bits of radio energy from one point to the other. Oh yeah, let's put on our, okay, as long as we're putting on our tinfoil hat here and bugging out, yeah, a lot of people claim, oh, Wi-Fi is going to hurt me. So yeah, you wear a shielded helmet if you run Wi-Fi. It's actually, the actual electrical energy expended by these transmitters is pretty slim. Although there were some cases of the New York telephone company people that maintain the microwave towers on the top of the skyscrapers came down with cancer and stuff like that. But anyway, there's not a political class. I won't go there right now. So speed, bandwidth. How much data can we shoot over a copper cable? or a fiber optic or a Wi-Fi radio transmission scheme. So bandwidth is a raw measurement of how much data can flow from one place to another place. So for example, we have this thing called Ethernet, which was the original method of plugging electrical wires together to create the first networks. Xerox Corporation invented Ethernet as a way of selling laser printers because the laser printers were so expensive that they couldn't buy one for every secretary. Now, some corporations have so much money, like Alcon. I worked out at Alcon when I worked for a contractor. Every secretary has got their own laser printer. But at this time, when Xerox brought out the laser printers, they were so expensive that you had to share them with 10 or 20 word processing secretaries. So Xerox invented the laser printer, and they wanted to sell a lot of them. It was a very popular product. So they invented the Ethernet networking scheme as a method of connecting 10 or 20 word processing machines to a single laser printer that was so fast you could easily keep up with 10 or 20 people typing in documents. So the bandwidth of this device was 10 million bits per second. Standard Ethernet is 10 megabit, 10 million bits per second. Now, remember we had 8 bits as a byte, and then there's a little bit of additional overhead for, error checking and such, putting things back together. So as a rough rule of thumb, whatever the bit transmission rate is, divide by 10, and that's how many characters or bytes or numbers per second you can be able to transmit. So standard 10 megabit Ethernet, that's about 1 million characters per second. So you guys that have got, if you're on the newest fiber optic system, you've heard the term gigabit networking, 1 billion bits per second. Well, that's about 100 million characters per second. I'll divide 1 billion by 10 and come up with 100 million. That's the bit. So a bandwidth has traditionally been measured in bits per second instead of bytes per second. So this bandwidth is available, but you have to share it with the other people that are using the network, and also as it gets broken into, has to be broken into small, manageable sized chunks to be transmitted over the network. Each chunk of information, we call these packets that are transmitted over a network, about equivalent to 1 printed page worth of information. I mean, about 1,000, 1,500. Think of a printed page. It's got about 1,000 characters on it, maybe 1,500 characters. So we have to break it up and then put it back together at the other side, and there's a little bit of overhead. And then think of your home network when everyone's streaming their TV shows and everyone's on the Xboxes. You got to share that with everybody else in the network. So your throughput that you get is going to be a smaller amount than the raw measurement. Now, use your network at 3 a.m. in the morning when no one else is using it, and you can get, your throughput will be pretty close to the raw bandwidth capability of that device. So we've got super fast connection at the campuses to our internet service providers, but we have 100,000 students. Well, if they're all showed up for class instead of using the computers, your individual speed, your throughput is going to be smaller than that because of all this overhead. Okay, local networks. In the next class, CCNA2, the actual technical correct name for this is local area networks, or LANs. And local area networks are characterized by it's all in one building, or maybe you have a local area network at home, and it's composed of some devices that give all these devices dedicated, 24-hour connectivity to the other devices in that home. You guys are probably don't remember the screeching cats modems that we would log onto in the 90s to our StarText and America Online and so forth. And they were fairly slow. But the local area networks that we use, let's go ahead and jump to the next slide and talk about this. Local area networks are characterized really by privately owned or in one building, 24-hour connectivity, and fairly fast in speed. Even the original Ethernet was 10 million bits per second. And now it's more typical that desktop devices are connected to the network at a gigabit speed, which is 100 billion words or characters per second. Okay, network components. Servers and clients. So a client machine, clients request services and servers fulfill these. So when you fire up your web browser and you go to the internet and go to a web page, your machine is running a client-based software like Mozilla, Firefox, or Chrome or Microsoft Internet Explorer or Edge or whatever browser you're using. That's a client software. It requests the server to give me his homepage. So client machines that have software that has software and allows them to request information and then display that information. So you click on a website, and under the hood, so far as we're concerned, it's Elven magic. Okay, some electricity flows through the wire, and the web page you clicked on appears magically on your screen. The servers are machines that run. If you go, for example, you go to Network Academy, netacad.com. That's a server machine. I think it's physically actually located at a data center in Arizona. And it will check your password, and then it will show you the classes that you are taking. And then you can click on chapter 1, chapter 2, and read this particular stuff. So servers have software installed on that allows them to provide information. As an example, if you have a desktop Windows PC, it's probably running Windows 10. There's some older version of Windows they're trying to phase out and force you to. If you have Windows 7, you can still get a free upgrade to Windows 10. You don't have to pay for it. Server machines run specialized software that allows them to serve up and transmit back answers to requests. So clients request services and servers fulfill these requests. They typically aren't Windows-based. They can be. Now, Tarrant County College is a sort of a Windows shop. So we have Windows desktop PCs because Windows pretty much owns the client software. These are the computers that employees and students and home users use typically. You could also use Linux. You could also use Macintosh. But server machines, we do have a lot of Windows service machines running in our college infrastructure, but it's more common for the server machines to be Unix or Linux based. So they have software installed on them, web servers that serve up these web pages that you click on. So servers are super heavy duty. They're built to be super heavy duty and optimized for the particular function of sending stuff back to you when you ask for it. Whereas client computers, they can be kind of slow. Client computers spend 99% of their time waiting around for you to hit a key on the keyboard. And then you click on a web link, and they spend 1 second putting that web link you clicked on your screen, and then they start loafing again. So servers can have multiple roles in a network. They can, for example, let's say you're a small business and you buy 10 Microsoft Windows 10 base computers for your 10 employees, and you buy a Microsoft server. And on that Microsoft server, and you want that one server to provide everything you need for your company. So it's going to be the file and print sharing server for your company so they can share the accounts receivable file. It's going to be the web server interface for your company web page you display to the world. It's going to be your email server for people that send and receive email to your company, and some other more technical stuff we won't talk about into the next things like name services and addressing services. So one server can do this. It can do multiple services in a network. So the platform, the background, the stuff that connects these together is called the network infrastructure. This is a lot of stuff that people normally don't see much. And the one you get to see is your home router. Your home router is a sort of a combination device. It's a combination, a router is a device that connects networks together. So your home router connects your home network to the telephone company or the cable company's network. And then the cable company's network connects you to the internet. And in industry and the business world, we typically break these out into separate devices. So they would have a separate box. If it was a business, they would have a separate device that was a router that connected the South Campus back to our home campus, Trinity River campus. And then we'll have Ethernet switches, and this is the device you're going to use in your first lab. Someone's got a question about problems with networking, passwords to the Academy, and let me address that after we complete this slideshow. So in a company, you would typically have, let's say, a router device that would connect to the home office, like we do at South Campus, and you have switches in each building to connect to each individual room. The question is, I have published a schedule, so I'm going to do some limited types of announcements, like when I post stuff that I normally won't send individual. This is not high school. You can look at the schedule and you can keep up with the schedule and stuff yourself. No late points, don't worry about that. Access point, that's a technical term for like a Wi-Fi access point. And these are all connected together using some type of, he says network media. That's a new term, media. What the heck is media? Is that the TV system? Is that the press, the establishment press? No, network media refers to, it's a twisted pair copper cabling that connects us together. Is it fiber optic cabling? Is it Wi-Fi? Is it telephone company, cellular network that are connecting us together? So end devices are devices that actually start the flow of data and then receive the flow of data. When you clicked on that web link in your client computer running Windows 10 and you started the flow of information going, you're an end device. Now the new buzzword in the industry is an endpoint. So an end device starts the flow of information going. And eventually another end device, a server, will accept your request and he'll give you the answer that you clicked on, and it'll come back and it'll pop up on your end device, the screen of your desktop you see. Intermediate devices are the devices that most people don't get to see very much. You get to see your home router, but you don't get to see real separate routers and switches and access points. When you come into our classroom, access point is a Wi-Fi device that if you come into the classroom, you'll see in the center of our Cisco room a little white thing attached to the ceiling. That's a Wi-Fi access point. So you can use we give free Wi-Fi to students in the community at every one of our buildings. We got excellent Wi-Fi throughout the entire system. So access point is like, it looks like a home router. It's got antennas and it does stuff out, but it's broken out. A home router is kind of like a router and a switch and an access point all in one box. So these intermediate devices connect everybody together, and they choose the best path. So when you pick up your telephone, it's an end device. You dial a number. An intermediary device back at the telephone company chooses the best path to cause the other person's phone to ring and connects you guys together so you can have your telephone conversation. So everything is either an end device or an intermediate device. So he says in the bottom about end devices, a computer, a laptop, a printer, tablet. This is where you enter your data, or you put your query in, or you put your request in for something, and the answer appears on that device. Now, let's look at building a simple network. And I'm going to talk about peer-to-peer networking and client-server networking. If you worked at a small company, you probably don't have a dedicated server machine. You probably don't have, because of the payroll expense, a dedicated system administrator or network engineer to tie everything together with. Instead, the owner of the company decided, we'll just go down to the Office Depot store and buy some computers and a printer and plug it all together and with stuff I bought there. And peer-to-peer network, Microsoft says a peer-to-peer network is something no more than about 10 or 15 people to share. Advantages: very easy to set up, very low complexity. Low cost. I talked about the cost of buying a dedicated server. I talked about the cost of hiring a network administrator or a system administrator to run these devices. So Microsoft, most of you guys are probably used to Microsoft Windows. In Microsoft Windows, if I have a file on my computer and I want to share it with you, let's say I'm the accounting clerk and I've got the accounts receivable file, and I need to share it with you because you need to put an entry in there. So in Microsoft Windows, I'm going to take my mouse, I'm going to right click on that file that I wish to share and click the button that says sharing. And it'll be shared for some other people to use. I can put a password on it if I want to. I don't have to if I don't want to. Now, the other guy has got a printer. He's got this printer is locally attached to his PC. Normally, he's the only one that would be able to print. But if I go to my printer icon in Microsoft Windows and right click and share the printer, then other people can share it because they're connected to me. I'm only the one that's connected to the printer, but the other people are connected to me. And then they will be able to send the information to my computer. And my computer will sort of be both a client and a server at the same time. He'll be a client machine because he's doing the stuff that employee does. And he'll be a server in the effect that he's sharing that printer to all the other people that need to print. I can put a password on it if I want to. So Advantage is very easy to set up. Simple things: sharing files, transferring files, sharing printers. Now here are the disadvantages, and this model rapidly breaks down if you have more than about 10 or 15 people at your company. There is no centralized administration. Things like if we've set passwords. Well, what if Bob, who's got the printer plugged into him, decides that he doesn't like Sarah, who's in the accounts receivable department, and he changes the password on her? I'm not going to let Sarah print. I've got a beef with her. You can't call the centralized administrator and have him reset the password. There is nothing. And the hodgepodge of passwords. I have to have one password to share the file, and I have to have another password for the printer. Now, believe me, I used to reset people's passwords. It's hard enough to get our people to remember one password, let alone 2 or 3 of them. So there's no centralized administrator to call up to do. There's no help desk. This is a small company. So it's very hard to maintain security. These are the types of companies that when you go into the break room, everybody's password is printed on a Post-it note stuck to the coffee maker in case you need to print to the printer or access the accounts receivable file. So not very good security. Scalable. What is scalability? Scalability is a feature that I can grow the network and it doesn't become cumbersome. So with a peer-to-peer network, once it grows over 10 or 15 people, it becomes overwhelmingly, it becomes too cumbersome. All these passwords to remember. No uniform security policy. And that guy, Bob, who had the printer plugged into his PC, and then he right-clicked on the printer and shared it, every time someone comes and prints a job to his printer, his PC has to slow down a little bit because it's having to do that extra work of being a little mini server and doing the stuff that's attached to that printer. So in a large organization, we're not going to use the peer-to-peer networking scheme. We're going to do something called client-server-based computing, where we have, the question is, sorry, I missed that. Let me pull this up again. The question is based, are we going to have demos for the labs posted in the recording presentations, or do you do them in the packet tracer software and submit them to the professor? So what I'm going to do on our Wednesdays on our lab days is I'm going to do, generally I'm going to have 2 posts. I'll have one post that shows how you get started and do it in packet tracer, if you don't want to do it remotely. And then I will have another one that shows how we do it on the actual real Cisco equipment in the lab. And so if you're doing it remotely, you would edit that Microsoft Word document and submit it to me by email. Let's see what other questions. Someone said they tried to log into the Cisco, but it's showing the wrong password. If you find yourself locked out of your the Cisco Network Academy site, you can click on that I forgot my password link, and they'll send you a link to your TCC email where you can reset that. So let's see, the question, access points and routers, what are the differences between them? In business, a router, you're probably thinking of your home router, which is a sort of, technically it's a combination of a switch and a router and an access point all in one box. But in industry, we break these out into different things. So when you come to the classroom, you'll see the access point on the ceiling of the classroom. And the routers and switches, they're back in the wiring closets where people can't mess with them. They're locked up. Okay, so I was talking about if it's more than 10 or 15 people, like 100,000 students and 4,000 employees, like the college district, we use the client server method. We have dedicated server machines, big data center downtown. We have a large staff of professional IT people that keep the system running properly. You can call a help desk number if you have a trouble with technology, have trouble with your Blackboard or your password. You can call a dedicated help desk staff, and they'll help you solve your problem. This is an additional expense. We have to buy all the servers. We have to hire all the additional administrators and IT people to run this stuff. But in a large company, that's a cost of doing business. You just have to do that. Hey, don't you voters remember you approved an $8 million bond election for the college back a little over a year ago? Yeah, we can buy all the new technology we need to. Okay. Now, let's look at this question about testing. There's this command called ping. You probably never used it. Pretty boring, but here's how it works. So the ping command is a special command that sends a sonar-like pulse through the network to verify that you're connected to another device. And it also tells you the time delay, kind of like what sonar does in a submarine. The sonar tells the submarine commander how many hundreds of yards it is to the battleship he needs to sink with a torpedo, and then he'll set his torpedo to explode when it gets at that particular range. So the ping command is a special type of very small network packet that transmits to the network. And when it gets to the receiving machine, assuming we have good network connectivity, in this diagram we've got a router in York, in London, and Paris, and Rome, and they're all connected together with leased telephone lines. And we're trying to test the connectivity between the York router and the Rome router. These little circles with the crosses in them, that's the icon or symbol that we use in networking to say this is a router. So your home router could be represented with the circle sphere with the X in the middle of it. So we can type the ping command on one device. You can do it on your desktop PC. For example, let's see if we have network connectivity between your home and the Cisco Network and Academy web server in Arizona. You could go to your prompt, your DOS prompt, your command prompt in your PC, and type the command ping netacad.com. And it would show you that you're communicating with that device, and it would also tell you the time delay between one point and another point. Now, some of you guys, are you guys gamers? You play these games where you shoot down the F-15 fighters and stuff like that? You probably know a little bit about this latency thing. So I'm going to ping the gaming company, and my latency is 500 milliseconds. That's it. I'm being shot down in flames. That's too much delay. The other guy's got 8 milliseconds. Oh, he shot me down because he had less delay. And this can be very important in things like in the commercial business world. If you're doing stock trading, minimal delays are very important. You could lose thousands of dollars if your delay is too low. Now, the ping is great for verifying end-to-end connectivity between two devices, but if there's a lack of connectivity for some reason, we don't know where it occurred. So it's a go, no-go type of thing. So in our diagram here where we have our 4 devices, what if there was a disconnect between, say, London and Paris? Ping only tells me that I can't ping Rome. There's no connection right now. So there's a more advanced, I call it ping on steroids. It's a utility called traceroute. And when I type traceroute netacad.com, it will show me a map of all of the routers that are in between me and that device I'm trying to see if I have connectivity with it. As a matter of interest, there's typically about 10 or 15 routers. These represent internet service providers and other companies. When you ping, when you trace route to any website in the world that you want to go to, there's usually about 10 or 15 routers between you and them. So in this diagram, the guy at the York router has typed the traceroute command. Says, how many routers are there between me and Rome? And he says, well, the London one, and then the Paris one, and then the Rome one. And it tells you the delay that he's getting between each one of them. So it's a sort of a super duper utility. And we're going to use this in the first lab to verify communication between our PCA and our PCB. Okay, I think that's about it. So that's another one for the books. So coming up Monday, we will cover chapter 2. Hang loose, I'm gonna go back to this again. Hang loose. So we've covered chapter 1. I've covered the course structure. I showed you the Cisco Network and Academy website. In the future, we will always meet like we did today on Mondays and have our virtual online lecture session. So on this next Monday, I'll cover chapter 2. And then starting next week on Wednesday, we will meet in person at SVS 1125 building and room location at South Campus if you want to come. Don't come if you don't want to. Don't come if you're sick. And you have the option of remotely using the free packet tracer. Oh, I forgot to show you how to download the packet tracer software. Before I quit, let me show you that real fast. Let's see. Wait a minute, I'm going to stop sharing this. I'm going to show the Cisco NetAcad site and show you where you can get the packet tracer software. I forgot to show you that. Okay, when you're logged into the Cisco Network Academy, you can go to resources and then it says download packet tracer. And then it's going to take you to a page where you can download the packet tracer software itself. So there's a mouse moving. Okay. There's 2 Windows versions. You probably have a Windows 10 computer. It's probably 64-bit. If you got a really old computer, you might use the 32-bit download stuff. They do have versions for Linux. I've never installed and configured the Linux version. If you're a Linux gearhead and like to experiment, use that. If you have a Macintosh, Mac OS, OS X version, there's a version that runs pretty well on that as well. There was a mobile version, but they've discontinuing that. Mobile devices, the screen's just not big enough to do that stuff. So as a review to that question about I'm going to log out of this. If you're having any password issues with Cisco Network and Academy, when you float over to login, you'll see something that says, if your password's not working, click Forgot Password, put in your email, your TCC email, and they'll send you a link to your TCC email inbox where you can reset your password. Can I make a suggestion? Whatever your password is for Tarrant County College, that password you logged in today to my TCC Blackboard, that'll be the same password you use when you come in person, by the way, to the business building. Make that your Network Academy password, unless you like remembering lots of different passwords, or you got a password manager. So that's how you'll cure that problem. Okay, so that's one for the books. I'm going to hang loose for a second here in case there's any more pressing, distressing questions, and then I'll call it a day. And I will place an announcement in the announcement section. It takes about an hour or 2 to process the video. And I'll let you guys know via the announcement page here in the first page of TCC Blackboard that the recorded presentation for this is available. Okay, I'm going to mute my microphone and hang loose for a minute. And thank you for coming to my class today.